Are. Darune, we are going to start. Okay. Now we are going to start properties of matter. Listen, Pute, this is one of the questions that most of advanced level students do or select, right, as their one essay question. There are several reasons for that. Number one reason is that very smaller section. And under properties of matter, there are three major sections as elasticity, viscosity, and surface tension. Clear? So today we are starting elasticity tube. There are few main equations, and with them we'll be working. Right. So with the word elasticity, you may be thinking elasticity. All right. Now you may be thinking we are going to talk about what? Rubber objects. No. You may be thinking we are going to talk about springs. No. Yes, we will discuss small, right, amount regarding rubber and springs. But this is not mainly about them. For this elasticity concept, we are going to talk mainly about for metal rods, concrete slabs, for such objects. Now it means, Pute, now you have an idea about elastic property. Elastic property, you have an idea. Normally when a body is given a force, you can move a body with a force. A body can be moved with a force. But think you have a metal rod. You have a metal rod. And you are giving forces like this. To a metal rod, you can give forces like this. And to a metal rod, again, you can give forces in opposite directions. Pute, to a metal rod, if you give forces like this, now think this is the original length. My metal rod can be stretched a bit. I'm not telling that is several meters. I'm not telling that several centimeters. It's sometimes few millimeters. So this is the original length. And with that force, that's actually a tension force. It's a tension force. With the tension force, the length has been increased a bit. The thing that happens is, when you remove that force, this metal rod, it may be a concrete slab, that comes to its original length and original shape. It means elasticity is not only for springs. Elasticity is not only for, right, rubber objects. We can talk about elasticity concepts even for these types of objects, metals, concrete, right, solid objects. Can you understand? So this is a tension force. Now the same object can be even compressed by applying forces like this. Clear? Now its length is less than the original length. Can you understand? Right. Enapute, what is elasticity? After you remove these forces, it should again come to this nature. After you remove these forces, again it should come to original length and original shape. If a body shows such property, you can call it as an elastic property. And objects having those properties are elastic objects. I think you got my point. Clear? Right. So now we are in page number 1 We are going to talk about elastic property concept. Elastic property. Right. So this is our unit number 10, properties of matter. Under that, elasticity. Pudha, let's fill the space like this. When you can see when an external force is applied on some materials, their geometrical measurements and shape change. Now start writing. Some materials obtain, you have space to write this. Some materials obtain their initial measurements and shape. The initial measurement and shape after removing that external force. After removing that external force. This property of a material is called elastic property. This property of a material is called elastic property. This property of a material is called elastic property. Elastic property. Then the objects with elastic property are known as elastic objects, and the object which don't have elastic property, are known as inelastic objects. That's clear. Haripute. Then I come to the topic distortion. Hari. Now listen. Darune, by giving a force, by giving forces, we can actually change the shape of a body in 3 ways. Right? So distortion means changing shape of a body, changing shape of elastic object by giving an external force. Putha, there are 3 ways we can change the shape. One is we can change its shape linearly. If there is a rod, by applying a force, you can increase its length. So it is linear, right? Or we call it one-dimensional distortion. And if there is something like a sheet with certain area. Now here length increase, here length change. Here you can give forces like this on the sheet and its area can be increased. So that is two-dimensional distortion. This distortion is sometimes even known as deformation. Distortion. And there's the third type, Pute, it's three-dimensional distortion or deformation. You can give forces like this. It's not always about, right, increasing the length or volume or area, okay? It may be even decreasing. As an example, think you have a body immersed in a liquid which can be compressed. Clear? When that object immerses more and more, what happens? Liquid pressure increases. Right? So that is also a distortion. Liquid pressure increase and volume decrease. We have to talk about the volume decrement. So when it immerses more and more, right, pressure will decrease the volume. So it's not always increasing. It may be changing the length, it may be changing area, or it may be changing volume. But here in our syllabus, we are mainly talking about this one-dimensional distortion. Can you understand? Right. So these diagrams are given. Distortion is the changing of shape of an elastic object due to external force. Deformation is 3 types: one-dimensional, two-dimensional, and three-dimensional. In this lesson, we discuss only regarding one-dimensional distortion. Okay? Right. But I come to Hooke's law. You know that. Lamaine, you know this. Think there is a spring. There is a spring. There is a spring in its original length. This is the original length connected to a vertical wall. When you give a force, what happens? It gets extended, right? You can even compress it. So we know this force and extension are direct proportional. But a similar thing happen even to a metal rod or concrete slab. We can't see that displacement. We can't see that distortion. Not visible actually, because that's a slight change. But still there is certain extension or compression. So Hooke's tell, right, that force applied is directly proportional to what again? That extension. Here in this lesson, right, we can use that extension as simple E. Extension or compression or whatever the change in length. Clear? So that is mainly explained under the Hooke's law. So then we can take what? Here either F equal Kx or F equal Ke. You know this K is known as spring constant if it is a spring. And a similar nature is there. But a similar nature is there to any metal object also. It has something known as a force constant. Force constant. Clear? When you remove the force, it comes to the original length. But then will it happen continuously if you are giving the force? Right? If you are increasing the force. Increasing. But this law is, right, valid only up to certain limit. We will be discussing more about them later on. Right? Because when a metal object is given forces like that, up to some extent it shows elastic nature. After that, it's not showing that nature. Clear? Right, so there's certain limit you can apply the Hooke's law. We will be discussing regarding that later on. Then to mema balagama puthe Hooke's law. The extension of a wire, please note it down. The extension of a wire is directly proportional. The extension of a wire is directly proportional to the load within the proportional limit. Within the proportional limit. So you can write here F proportional x, F equal Kx, right? So you have to write only up to here in this page. F equal kx. F equal kx. Now turn page number 2, Bhute. Turn page number 2. Page number 2. Here, K is known as force constant of the wire. Write the units Newton per meter or mt minus 2. They are the dimensions, mt minus 2. Okay, right. Daruni, now we got a very simple equation. Actually, you already know that, but we early thought it's only to springs. So today we realized we can apply the same equation even to solid other objects like metal rods, metal slabs, concrete slabs, only up to certain limit. Clear? Right. And now our next topic is strain. Stress that term, sorry. After that we will be talking about strain. Stress. Puta, think there is a rod like this and you are giving forces in this way, no problem. Compression force or right extension force. If the area is A here, stress means this force divided by area. So simple. Now you are asking, it's the pressure. Yes, stress and pressure both have same units, Pascal or Nm minus 2. Can you understand? Is it clear? Right, so this is about elastic concepts of, right, rods or something like that, no? Can you understand? So you will be noticing here, what we have explained as pressure, same thing is using here. Use because if there is a table with 4 legs, the table is not like this, you know, with 4 legs, right? When there is a person or any object, forces are acting on each leg, right? Sometimes the forces will be distributing equally, the force, the weight will be distributing equally. Sometimes it will be different. But anyway, each leg will have certain compression, right? And there is some sort of pressure nature. Clear? If you consider an area. So that is there. And what is stress? Force over area. It can be even, right, force like this, which is increasing the length, no problem. Anyway, what is stress? Force divided by area. Units are Nm minus 2, even Pascal can be used. No change. Even dimensions are the same, ml minus 1, t minus 2. Right, so let's note it down about stress. Right, like this. Stress is defined, you have enough space to write everything. Stress is defined as elastic force acting on unit cross-sectional area of a material. Unit cross-sectional area of a material. So stress equal elastic force divided by area. Sigma, the symbol. Dimensions ml minus 1, t minus 2. Stress is a scalar quantity. Stress is a scalar quantity. Hari. Hari. After that, we count our next concept. Hari. After that, I come to strain. Darwane think there is a rod-like object. Initial length is L, simple L. And after giving a force, now its length has been increased by an amount equal to E. E is the extension I have selected. Okay? So now you are thinking, I know whether area is changing. Normally area should change. Can you understand? So you will notice there are questions, right? Sometimes we have to consider that area change. But in most of the cases, you don't have to think about that area change because this is a slight increase of length which doesn't occur any change in area at all. Okay, right. So initial area A, still it is A, you can consider because E is very small amount. Can you understand? Right. Then our equation to the strain, Putha strain is very simple, is the change of length divided by initial length. So simple. That may be either compression or extension. Can you tell me what should be the units? Extension is in either meters or centimeter. Let's take meter. Length also has meter. Meters get cancelled. No units to strain. No dimensions. Strain, I think it's clear, right? Change of length divided by initial length. Right. So it's about strain. Write the equation. Strain is equal to change of length divided by initial length. It has no units and no dimensions. Haributa. Now listen. You know what is stress and you know what is strain. Puta, stress is two types. Strain is also two types. There are two types as tensile stress and compressive stress. Strain is also two types, tensile strain, compressive strain. In a situation like this, Pute, the force decrease the length. The force decrease the length. If the force decrease the length, we call it a compressive stress. Here you have a stress, but the stress here FOV, stress is FOV, but you can call it as a compressive stress. Right? And the strain is known as, yes, equation EOL is the change of length divided by initial, but we call it compressive strain. In this moment, as the length is increased, yes, stress is FOV, but it is tensile stress. Clear? And the strain is EOL, we call it what? Tensile strain. Clear? Right. So, that point we will be writing when the length increases, the stress is known as tensile stress. And the strain is known as tensile strain. When the length decreases, the stress is known as compressive stress and strain, and the strain as compressive strain. Haributa. Now you know there is something known as stress, which is equal to FOV, something known as strain, which is equal to EOL. Now I am going to give you the most important equation that you will never forget in this section, elasticity. That is, in elastic limit, stress and strain are directly proportional. So stress is direct proportional to what? Strain. Stress is direct proportional strain. It means Pute F over A proportional E over L. Now what you can do? We can take a constant. F over A equal a constant times E over L. In some books, this is given with the letter capital E. That's also, there is no problem. We call it as Young's modulus. Young's modulus of the material. Actually, that's for solid objects. Clear? Young's modulus of the material. Now, this is our main equation. F of A equal Young's modulus times E over L. Clear? Can you tell me if E over L, E and L both have same units, Actually, stress EOL has no units. But FOA has units. You know what should be the units of Young's modulus? Same as stress. Now you can remember then Young's modulus, stress, pressure. Young's modulus, stress, pressure. All of them have same units, same dimensions. Clear? Young's modulus, stress and pressure. Right. So this is the equation. We can do more questions with this. Right. Today we will be doing questions after this. So this is the point. The stress, you can put a star there to that statement or underline or highlight whatever the thing. Stress is directly proportional to the strain within the proportional limit. So we get this equation. Here we call it as what? Young's modulus. Young's modulus. Young's modulus. We call it as Young's modulus. Hardhabuta. Now we are going to do questions. Hari, so theory poddai mage bote. Yes, you can see 4 pages. 5 pages, right? Yes, 5. That's all theory. Then we have questions. Yeah, elasticity, that's all. That's all. Elasticity HRI. Right? We have questions. Let's start now. Now already you got how many equations? 2 equations. One is F equal Kx or F equal Ke. Both are the same. Next one, F of A equal Young's modulus times E of L. So let's start these 2 questions. Number 1 and 8. 1 and 8. Hitala kamu hai? 1 and 8. Everyone start now. 1 and 8. Patan ganna pute. You have to do the questions. Alright? You have to do the question. If you are just going to write the theory and stay watching the video, whatever the thing, that's not going to work. You must do questions. Try the questions. Start everyone. 1 and 8. Question number 1 and 8. Start now 1 and 8. 1 and 8. Do the two questions. I'll give maximum 2 minutes more. We have to do the question. Hurry up, everyone. Haributa, time is now. I'm coming to the first question. It tells, listen now, number 1, steel wire, length 6 meter, area 4 centimeter square is subjected to a force 6.8. If the Young's modulus is 2 10 to the power 11, find the extension. Put F of A equal Young's modulus times E of L. Force is 6.8. Area 4 centimeter square. I multiplied by 10 to the power minus 4. Right? Then this is 2 10 to the power plus 11. You have to understand this converting centimeter square into meter square. Extension is the thing I'm asking. Length is 6 meter. Clear? So this gives us E value. 6.8 into 6 divided by this giving us 8, 10 to the power, these two get 7. Okay? So we can find a value for E with this. E value. (5.1) is it? 5.1 10 to the power minus 7 meters. Okay, our next question. Number 8 now. Light rod 100 centimeter is suspended by 2 wires A and B of equal length as shown. These two should be at the 2 ends. Hari, I'm asking if area of cross section of A is 1 millimeter square and B is 2 millimeter square. Put it to this wire, area A1 1 millimeter square, to the second wire area A2 2 millimeter square. Okay? At what point on the rod should a load W be hung in order to make equal strains? So you are going to hang W weight. You are going to hang W weight at certain location. I select this distance to be X. Then how much is this distance? 100 minus X. Can you understand? So forces on the rod. You have F1 force on the left side of the rod. F2 force. Due to these forces, the two strings will stretch at them. But this is the force on rod. And on the string, what is the force direction? Down. Can you understand? We are not labeling a force on the string here. This showing force on the rod. Force on the rod. I think you can remember that. Normally, when we draw an object like this, when I'm asking you to label the forces, you label W, the weight, mg. And tension T. This is the force on what? Object. That the force on object by string. Then string has, if I ask you to label force on the low end of the string, that is downward T. So this T and this T are action-reaction pair explained under Newton's third law. Action-reaction. Can you understand? Clear? Right. So actually what we are labeling is the forces on objects. So on the string down, so that downward force will extend the wire. Now I'm asking if both are giving same what? Same strain. Same strain, right? Both are giving same strain, then what should be the location? X value hoyamaputa. Now I am going to take moments. Let's take moments about this point. I'm taking this point as P. So when you take moments about P, W can't create a moment about P. But F1 can create a moment. What is the moment by F1? F1 into X. That should be balanced by the moment F2, right? So it's F2 into 100 minus 6. I'm writing moments, anti-clockwise moments about P, right, equal clockwise moments about P. So this is F1 into X equal F2 into 100 minus X. Right? What is F1, Pute? F equal, F over A equal Young's modulus times E over L. Now E over L is constant. So someone can write F as Young's modulus area times E over L. Clear? Now I am going to put that to the equation. See this one. F1 is what? Y1 A1 E over L times X. This is F1. What's F2? F2 is Y2 A2. Clear? Can you understand? E over L times 100 minus X. Now what was given as the same? E over L was given as the same. Strain is same, it gets cancelled. This is given to the first rod, 2 10 to the power minus 11, 2 10 to the power plus 11, sorry. Into area, no problem. I select it as 1 because both sides millimeter square will get cancelled. No need for that unit conversion now. Both sides we are going to put millimeter square. 1 into X equal Y2, 1.6 10 to the power 11 into 2 times 100 minus X. So 10 to the power 11 also gets cancelled. This gives 2X equal, can you understand? At the number 2 also get cancels, right? So X equal 1.6 times 100 minus X. Is it clear? Clear? Enabuta X equal 160 minus 1.6X. 2.6X equal 160. This gives us X value 160 divided by 2.6 centimeter. So you can find X value Buddha with this in centimeters. X value 160 divided by 2.5. 61.5? 61.54. 54 cm. 61.54 cm. Complete, everyone. Okay. Hari. Hariputa. Let's start 5 more questions. Now MCQs. MCQs. Pute, now you will see we have only 2 equations. Again, F equal either KE or F of A equal Young's modulus E of L. I'm not going to use any other thing. That's all. The concepts you know. But out of this is a property to a material, to a solid. Copper has certain value. Aluminium has a different value. Concrete has another value. Can you understand? So different objects may have different lengths. Clear? Different areas. With the force given, right, then E will change. Right. So now you start these questions. 10, we are starting MCQs. 10, 11, 12, 14, 15. Hurry up, Pute. Right? Work. Do the questions. Equations are given. Do the questions. Start, everyone. 5 questions. Buddha, do the question set. Hurry up. I have given you 5 questions, 5 MCQs. If you can't work with number 10, go to number 11 then. Do at least several questions out of these 5 questions given. I know there are things you have to think. හිතලා උත්තර ගන්න ඕන. Do at least 2-3 questions. Don't stick to one question. There are 5 questions given. If one is difficult, go to the other one. Hurry. Haributala, I'm coming to the questions. Listen now. Everyone. Right? Number 10 Agam. Mepetta Balan. A uniform elastic wire is suspended vertically from the ceiling and mass is hung from the bottom end. Number 10. There's a mass hanging from the bottom end. Consider the following statements assuming that proportional limit of the wire is not exceeded. A. If length of wire double, strain of the wire double. Oh, hey, innepa. The mandana lamaitona mehmo kakkaridana. I don't know why you are not even writing an equation. You just need an answer. You think physics in that way. Right? With the equation work, put F over A equal Young's modulus E over L. Then think with this. Statement A. When length double, okay, I double L value. Right? That's the only thing I change. That's the only thing I change, right? So now you think accordingly. Did you change the force? No. Did you change the force? No. Did you change the area? No. Did you change the material Young's modulus value? No. So here everything is the same, no? Enang, if this is multiplied by 2, this should also get multiplied by 2. You have to think. You are not even writing an equation. These things you can do. What I am telling you can do them. You are not doing. You just need an answer like this. The tick. So now you tell me what is it asking? Strain double, puta. Extension double. But what's the strain? Same. 2 get cancel. Strain is the same. Extension double, but strain is same. So A is false. Statement B now. Area of cross section of wire double, strain of the wire double. Let's think. F over A equal Young's modulus E over L. Now what are we going to make double? Area. Did I change the force? No. Same material. Did I change the length? No. I didn't change the length. But with the properties E change. Now with area E change. What will happen to E? E will become half. E will become half. Was in the left side here? Half. Half. Enaputa. Strain doubles. Does it double or is it half? It's half. B is also false. Statement C now. If the hung mass double, strain of the wire double. Anyway, Puta, it must be correct because all the others are false. Our answer is third answer, only C. Now number 11. It's asking a mass is attached to the low end of a vertical elastic string which is rigidly fixed at one end. The mass is then moved downwards with a constant velocity by applying a force F. Puta, you are moving the object. When you move the object, what happened to the length? Increase linearly. Can you understand? Length increase when the end is moving with constant velocity, length is increasing linearly with the time. And if I draw, extension is increasing, length increasing means actually extension is increasing. And extension variation with the time should be like this. What is the thing I'm asking? Force variation. Puta, F is proportional to E. And it's clearly given that you have a constant velocity. And Puta, if F and E are proportional, F should vary in the same way. Answer is answer number 1. First answer. Now next question. Number 12. Here E variation F. Puta, question has given figure shows variation of extension E of two wires X and Y. If one end of X is connected to Y from long single wire, the extension E with F for the composite wire is best represented by. Darwani, think now when you hang separately, here the variation of extension width for X, with the variation for extension for Y. Clear? So early separately X force given a force. Then separately Y was given a force. Y was given a force. Then extensions vary in different way and it's drawn in the graph. Now both are connected together, X and Y. Both are connected together and you are giving the force. But the given force will be acting on each cross section. When a tension is given on a string, the tension is there on each cross section. The particles feel that force. The particles feel that force. Each cross section. In a same force is given. Imagine when 2 Newton force given, this has 1 millimeter extension, and when 2 Newton force given, this has 1.5 millimeter extension. 1 millimeter extension with 2 Newton force. 1.5 millimeter extension with same force. Now when you give 2 Newton force, what happens? X will extend by 1 millimeter. Y will extend by 1.5 millimeter. And it should be what? Addition. And now we are going to take extension force graph. It is the addition. It is the addition. So addition means may dekata match. So here there are certain points given. I think addition is given in the third one. Is it 3 or 4? Addition. You how to do that? Haritama karne diye kya? Haritama karne. Pute, you can measure this length, okay? This smaller gap. Imagine that is 2 millimeter. Then you can measure this distance. Imagine that's 3. 2 plus 3 how much? 5. That's the way to get it, clear? And you can measure this length. Listen, Bhute. You can measure this length, imagine that's 4 millimeter, here to 8 millimeter, then it's the addition. Right? That's the very correct method to do that. So I think if someone is doing in that way, it gives the answer. It's not one. We have a small problem here. It's not to the correct scale. It means everything should be to the correct scale. I feel that it should be answer number 3. It's because fourth graph, it can't be the first one. It can't be the first one. It can't be the second one. Now we have 3 options. 3, 4, 5. Clear? But when we think 4 and graph y have the same shape. 4 and graph y, 4 and graph y have same shape. Clear? So in that case, the most suitable one is the third one. Clear? It's better if it is given in a more suitable way. Graph should clear madi. But the answer here I'm selecting as answer number 3. Harida, take the concept. Okay, that's the addition. That's the addition. Now 14. 14 tells 1/8 of a wire of initial length L and cross-section area A is fixed to the ceiling and other end is attached to weight W. When the attached weight reduced by half, extension of the wire is found to be reduced by length equal to L over 10, Young's modulus of the material. Put understand. Here delta F is given. Change of the force is what? W over 2. Initially W was given. Then we make it half. You know what is the change of force? W over 2. Clear? And what is the change of extension? That is L over 10. Understand? This showing delta E. Change of extension. Did you understand my point? Change of extension. Hari? Enang. When you have a change in the load, weight, there's a change in extension. Now our equation. F over A equal Young's modulus times E over L. Puda, now someone can write delta F over A equal Young's modulus times delta E divided by L. So this is W divided by 2A. W over 2, no? Young's modulus times, what is E value? L over 10 again divided by L. L is the initial length. Now L get cancelled. We can take Young's modulus value. L cancels with a 5W divided by A. Answer number 2. හරි. මගේ පුතේ next question number 15. ආන්නකෝ an elastic string ලස්සන question එක. Elastic string has length 30 centimeter. අහන් ඉන්න. When tension on it is 3 Newton. පොඩ්ඩක් අහමු පුතේ. Elastic string has 30 centimeter length when force is 3 Newton. When tension is 4 Newton, length become 32. හරිද? If tension increase to 7, length of the string. ඔන්න බලන්න මම කරන විදිය. So with 3 Newton force, how much is the length? 30 centimeter. When you are giving 4 Newton, ඔන්න length become 32 centimeter. ඔන්න දැන් හිතනවා. එහෙනම් පුතා, what is the change of force here? What is the change of force here? 1 Newton. 3 become 4. Then length of the string increase means extension increase. You know, what is the change of E? 2 cm. Can you understand? And there you can understand. To 1 Newton we have 2 centimeter change. Clear? To 1 Newton you have 2 centimeter. Now I'm asking, when we give 7 Newton, what should be the length? Pute, 7 Newton means, what is the gap between these two? 3 Newton. Between these two, 3, right? And change in extension between these two should be how much? 6 centimeter. So it should be 6 greater than this. How much? 38. If you are going to do it in another way, it will be difficult. This is the easiest way. Answer number 2. Okay, Buddha, hands up who got all the answers correct? Good. Hurry. Now can you understand something? Hurry. So, සමහර ඒවා පුතා කොයි තරම්නම් කී වතාවක් කිව්වත් තමන්ම කොයි තරම් අත්දැකීමෙන් දැනගත්තත් you are not changing. මොකද? ඔයාලා A level physics කියලා ගොඩක් අය හිතන් ඉන්නේ equation කටපාඩම් කිරීම. හරි term test එකක් ලං වෙලා equation ටික පාඩම් කරගත්තා යනවා. ඔයාලා A level physics කියලා හිතන් ඉන්නේ value substitute කිරීම. ඕක කොයිතරම්නම් කිව්වත් කොයිතරම්නම් බෑ කියලා දැනගත්තත් ඕකමයි කරන්නේ. වැඩි උනේ කොහෙන් හරි සර් කෙනෙක් equation ඔක්කොම ටික පොඩියට ගහලා කොලයක් දුන්නත් අම්මට උඩු කියලා ගන්න. right? පුතේ ගණන් හදලා ප්‍රැක්ටිස් වෙච්ච එකට F equal ma දෙන්න ඕනේ නැහැ. දෙන්න ඕනද? පිස්සුද පුතා? V equal u plus at දෙන්න ඕනේ. වලට හැබැයි equation එක දන්නව apply කරන්න මතක් වෙන්නේ නැහැ. හරිද? pressure equal force of area දන්නවනේ. upthrust equal v/g දන්නවනේ. ගණන් හදද්දි එන ගන්නව නේද? what is important? practicing. practice එක හොඳට තියෙන එකගේ equation ටික blood වල තියෙන. physics එක blood වල තියෙන. හරිද? artificially ගන්න යන්න එපා physics subject එක. artificial physics subject එක ගන්න තරමට ඔයා weak වෙනවා, දුර්වල වෙනවා. මම කියන්නේ equation තියෙන එහෙම කොලයක් අරගෙන phone එකක දෙයක් බලන වෙලාවේ equation එක කඩපානකට කමක් නැහැ. that's fine. phone එක බහුබූතයක් ගන්න වෙලේ ඒ වගේ එකක්. but it's not the only thing. equation මෙහෙම කොලයක තියන් මම දෙන්නම් paper එකක් ලියලා බලන්න 50ක්වත් ගනින්න. Now you do these questions එනම්බා. තේරෙනව නේද මං කියන්නේ? ඉතින් දැනුත් කරන්නේ with the same equations. හරිද? ඒකයි කතාව මගේ පුතා. equation set එක දෙන්න පුළුවන් අපිට. ටක් 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 ගාලා. ඒකනේ මේ වැඩේ. එකම equation බලන්නකො කොච්චර applications හිතා ගන්නත් බෑනේ. Right. So now I'm not going to do anything else. No any other theory. Let's do some more questions. 16. Right? Because it's without practicing. If you need a theory, no, it's practicing the question. Right? Theory pot nahi theory dekkane theory ka bhi karagamu, don't worry. 16, 19, 20, 21 and I will give another one. Hurry up, hurry up. That's enough. Okay, that's enough, Pute. I gave only 4 questions. Start these 4 now. Start these 4. Start these 4 now. I gave only 4 questions. Both are these 10 and 19 are the same questions, right? So we will remove 19 and I will give another one. 10 and 19 are the same questions, ne Buddha? You start doing. Do 28 instead of this. 28. Do 28. Hurry up, Pute. Hari Buddha, let's start. The question said, now number, everyone come, 16. Buddha 16 tells, one end of a metal wire length capital L and cross section area A tied to the ceiling. The other end is connected to a massless spring of spring constant K. A body of mass M hangs from the free end of the spring. If the Young's modulus of the material of wire is Y, total extension, very simple. Ne? Total extension. Put F equal Kx, mg equal Kx1, x1 equal mg divided by K. Then to the other one, F over A equal Young's modulus times E over L, mg over A equal, right, divided by A, L, equal E here. I'm asking x plus E addition. So it is mg over K plus mg L over, this is what? AY. I can take mg out, 1 over K plus L over A times Y. Okay? Then Harda Bhutar. Next number. Number 20 now, right? A material, the material of wire X has higher value for Young's modulus than wire YR. 20 is explaining about X and Y. According to the question, Young's modulus of X is higher than Young's modulus of Y. That's clear, right? That's clear. When two wires are subjected to same tension, extension of wire X is found to be more than Y. Put extension of X is greater than extension of Y. Can you understand the question? Same force given. Then it's asking, consider following statements. Api balamu kitin, write the equation. F over A equal Young's modulus C over L. Harida. So we don't have to worry about the force because same force is given, no? Etokata pute onna now consider A. consider x, sorry. When you consider x, ඔන්න බලන්න අපි දන්නේ මොනවාද? Its Young's modulus is higher. නේ? And its area E is also high. ඒ දෙකම වැඩි. එමනේ? So now if you take L මේ පැත්තට F constant L over A Young's modulus E. Okay? Now Buddha, E and Y both are higher to X. Ne? And what should be higher here? L over A ratio should be greater. Ne? That's what suits, right? Did you understand? You can't talk only about L. You have to talk about L over A. And Buddha, the correct answer is A. Am I correct here? Did I put it? Huh? No. This part is clear, right? A. I didn't explain anything. A tells above will happen only if diameter of x is no, only if katamak ne. B. Above will happen only if ratio of original length over diameter of x is greater than y. Original length of diameter. Yeah, that suits. Because here and area diameter is there, no? Harida. C. Above will never happen. No, this is correct one. Answer is second answer B only. Harine puta? Ela. Okay. Hari. Next one. Now number 21. 21 tells, consider situation where weight W are placed on vertical rods R, 2R, 3R, 4R respectively and made of same material as shown in the figure. If the rods have same length and not attain the proportional limit, variation of compression with radius. Okay, so write the equation F over A equal Young's modulus times E over L. But what you have changed, area is different for different situations. Area is different. So area is what? Pi r square. Now I can write F over pi r square equal Young's modulus into delta L, that the compression, divided by L. Clear? So I am taking delta L as the subject. It is going to be, right, F L over pi Young's modulus times 1 over r square. Same load is given, F same. You have same length, same material, pi is a constant. And delta L is proportional to 1 over r square. And delta L versus r. When r increase, delta L decrease. So this should be the shape. Clear? When r increase, delta L decrease. Answer is answer number 1. හරි. පුතා දැන් පුතාලා කවුරු හිතුවත් can't it be the third one කියලා? No, it can't be because yes ඒකෙත් පුතේ when r increase delta L decrease but මේ මොකද්ද මේ graph එක? this y equal minus නේද? mx plus c graph එකක් මේ. you have a constant negative radian. minus mx plus c. එතකොට අපි හොඳටම දන්නවා මෙන්න මේක y proportional x නම් පුතේ 1 over x නම්. how is yx graph? ඔන්න බලා ගන්න. how is yx graph? this shape. ඔලුවට ගන්න. දන්නේ නැති දරුවෝ. if we have y proportional 1 over x square then how is yx graph? same shape. හැබැයි ටක් ගාලා කලින්ට වඩා ඉක්මනට drop වෙනවා. so these things if you don't know, right, you should study පුතේ. for this relationship, here yx, here yx. Okay. This part is finished, right? මේක චුට්ටක් මේක අල්ලලා ඉන්න මේ පැත්ත. අපි ඊට පස්සේ ගමු. It is finished. This one. Okay. Right. Make gum. Puta, here additionally I am giving another one. Y proportional x and y proportional x square. Here if you draw yx, it's linear graph. Here x square nam pute yx is having this shape curve. Okay. Here the drop is higher, a greater drop is there. Right. Then Pute, I'm coming to 28. Darune 28 tells, listen everyone, two light rods of initial lengths L1 and L2 ආගන්න පුත, having equal areas of cross section are joined end to end. ආගමුද? And a force F is applied as shown in the figure. If the respective Young's moduli of materials of rods are E1 and E2, ආගමු, then පුතේ නිශ්ශබ්ද වහගන්නකෝ, they will contract by same amount when. So you are giving force, same force given. This has Young's modulus E1, length L1. This has Young's modulus E2, length L2. Okay. What is same for both? What is same for both? Contraction. They will contract by same amount. It means E. Both have same E. And then make that equal. You can take this E1, E2, make them equal. HRI. Put our equation. F over A equal Young's modulus times E over L. So what is E value? F L over AY. එන පුතා E1 equal E2 F L1 over A E1 බලන්නකෝ equal same force L2 length same area E2 Young's modulus. So what should happen Pute? L1 over E1 equal L2 over E2 name. It means E2 L1 equal E1 L2. What is the answer? Answer number 2. Answer number 1. Thank you. Answer number 1. Same compression. These 28 questions. Same compression. Hariputa, now you understood. In theory, I gave only 2 equations. Pute, there are, right, a few more equations in the under elasticity. With the next class, we will be discussing them. But with the same 2 equations, F equal Kx or F equal Ke and F over A equal Young's modulus times C over L, I'm going to give you few more questions as homework. Clear? As homework. So let's label them. Putala ogala karagana inne, that's a must. Then it takes only 2 hours katawa yanawane puta. Syllabus එකේ unit දෙකක් ඉවර වෙන්න යන්නේ මේ. දන්නේම නැතු unit දෙකක්. හරිද? Right. So these are your homework. Question number 6. (23), 24. There are some nice questions. Try them. Compare them. Discuss with friends. 25. Harida. 23 දෙකක් තියෙනවා. ආපුතේ this is page 1223. This is page 1223. Okay? Thank you. And 27. Shh. Then another 23 is there in page 13. Balannako. Another 23 is there. Do you want that one? (31), 33, 34, 35. That's all. Your homework. So these are the only equations we'll have to use again. Right. So Pute, let's meet with the next class. Elasticity. Homework.